Good afternoon, good morning, and good evening. Welcome to EIG's 38th webinar, Unleashing the Digital Twin to Accelerate 4.0. Today, we are in our second series of webinars on digital twins, and the other webinar is on our EIG website. You're welcome to view that at any time. This webinar is a demo, so it should be a lot of fun. So Hosni's going to show us his bag of tricks on a real live customer and show you what a data-driven digital twin is. So very exciting. So as we know, implementing digitization is in a streamlined manner is one of the greatest challenges for companies today. With limited resources, speed to implementation challenges, while not negatively affecting the current workflow processes, is what we focus here on. And Hosni focuses with CreateASoft. So this is applied to everything from healthcare to logistics to manufacturing to call centers to just about anything you can think of. Simulation has been used, and for over almost 30 years now, SimCAT has been leading the way. So very exciting to have them as part of our EIG webinar series. With the advent of digital twins, IoT, and cloud-based solutions, tracking everything from tooling, consumables, to the job itself as it winds through the factories has always been that challenge. And today with Wisers, we can track everything from the floor, the consumables, and bringing in any other IoT information, we're able to track that. So that's what we're going to talk about today. Again, please do have your cell phone handy or another window open on your browser to log in to polev.com / Jim DeVries. And then if you would, 073, Jim DeVries 073, sorry. Again, we appreciate you taking time, especially in light of COVID, to be out here and attending the webinar. We hope that your family is safe and well. Again, my name is Jim DeVries. I'm the founder and president of Enhanced International Group. We're a group of over 50 companies that specialize in consulting to SaaS solutions. And we are dedicated to empowering your organization's workforce by leveraging the EIG Partnership Network to support your needs. Our goal is to provide collective, collaborative, experienced thought leadership to enable organizations to deliver self-sustaining margin growth, providing you that competitive advantage over and in the marketplace so that you can thrive. We hope that this information is helpful to you, and all this information will be eventually put up onto EIG website. Attending the webinar and registering your access to the slides. We do have a few webinars upcoming on Thursday on de-risking, next Tuesday on supply chain risk and resiliency, and on Wednesday we're going to have a very interesting discussion on the trade-offs between lean, supply chain risk management, and DDMRP. So we want you all there so you can we can have a very interesting conversation. So that's next Wednesday. Again, we look forward to a good webinar. This is the second of the series of webinars. We had our webinar back in March or so on leveraging digital twins. Again, you can look at that at any time. Click on this link once you get the slides. And then today we're focusing on manufacturing workplace and webinar 3, which will probably be in September. We're still planning that out, and it will probably be in the warehouse management area, but we've done a lot of things in supply chain. So there'll probably be other webinars after that in other industries. For today's agenda, we have a full agenda, and just to prepare, we might go over 60 minutes. It will be recorded so you can watch later. We'll show you as much as we can within the first 60 minutes. But first, we want to give you an overview on the roadmap to Industry 4.0, our viewpoint for smart manufacturing, and then we'll get into the data-driven digital twin and then the demo with Hosni, and then and he'll show the value stream, the piece flow, the consumables and tooling, on how it all connects together with a live customer. And then we'll just cap it off with the CreateASoft 90-day plan on this can be done. It doesn't take 6 months or a year to do this anymore. Hosni's worked on very hard to make this something that can be achieved in 90 days. So with that, we just want to talk just a little bit about some of the 5 major stages in a business transformation or a manufacturing transformation. And those are, excuse me. Those are organize, standardize, visualize, stabilize, and optimize. And in organize, of course, this is like the 5 S's. We have to understand where the data is, understand the data sources, understand what the entitlement of our organization is, just like if you were doing 5 S's of your garage or a workplace, it's the same concept. We need to standardize so we can understand how our performance is relative to that process entitlement and the design entitlement to confirm the areas to focus. And then we want to identify what are those constraints and trade-offs. And then we want to visualize through value stream mapping, confirm available data, create data collection systems. So we really want to be able to see what is out there, and then stabilize the process, and then optimize through the design constraints. So generally, this whole life cycle takes quite a lot of time. And what Hosni is going to show is how we can do this very quickly in 90 days in a targeted pilot area. So first, I want to cover what Spinweiser provides. Spinweiser provides the visibility into the tooling, the consumables, all the things that you need to make the product. So these are very often overlooked as low valued items, but in essence, they're very important and they can hold up the higher cost items. So Spinweiser consists of a totem, and you can see the totem there in here where it's beside the shop floor. And then it's out on the shop floor here in the orange, and then here in the storage area or the tool crib. So we'll install those there. We'll also install what we call Spinweiser devices, these little things here that are locally with on the manufacturing floor that holds the tooling. So the folks on the floor no longer have to go to the tool crib every time they need a tool. It's tracked there in the usage and the trends on it. So you can always ensure that you have the tooling that you need when you need it, and you don't have to go hunting for it. And you can always ensure that you're ordering it from a stocking level perspective. So it's tracking your minute by minute inventory levels and your auto reordering based on the current safety levels. So it's real time. It's a form of a digital twin that it connects to your MRP system, or it can end up connecting directly to your vendors. So the Weiser system consists of a tablet, or you could use your cell phone, pretty flexible software. And the tracking of devices could be through smart lockers with locks, or it could be with shelves or shelving that's out there today, and you put locks on them, or specific smart lockers that are created. And you're tracking the in and out, ingress and egress of all your different components that you need, all your consumables that you need. And then the Spinweiser, as you can see here, that has 75 different compartments and 5 doors. It's a carousel. It's again on the shop floor, close to your CNC machines. And that device is part of the system so that you can track all those consumables. So really, everything's right at your fingertips through a cloud-based system that you can be on-prem if you like, and providing you that real-time reporting of all your consumables. So at the shop floor and your management have clear understanding of where all your consumables are. You're never going to be running low on any consumables holding up jobs. And just if you look at the wait time from finding a consumable, having to walk to the storage bin and a storage area and coming back, just by savings alone on time invested in producing parts is greatly enhanced. So that's Spinweiser. So that's a pretty unique system that's out there. And with that, I want to move on to a polling question as far as your concerns in deploying a digital twin. What are your top concerns of deploying a digital twin? Is it IT pushback? You need to have an operator standards first, data accessibility and availability, cost of implementation versus return on investment. Do you have challenges with integrating with other systems, productive disruptions when installing the system, training of personnel, readiness for digital transformation? So if you're looking or you have performed a digital twin, have you encountered any of these concerns? And when you go to the poll EV, as it shows at the top of the screen, .com, Jim DeVries 073, you can start ranking them. So the ones that are coming up at the top, interestingly, Hosni, cost of implementation versus the return on investment. That's very interesting since we just got done reviewing your ROIs and they're all between 1 and 3 months. Pretty incredible ROI for the digital twins that you've employed for the last few years. The readiness for digital transformation we often see. Folks are saying, wait, we got to do something before we get started. Give us some more time, which probably may or may not be necessary. Integrating with other systems is always a challenge. Would you say, Hosni?
Yep, that's another big one.
That's a big one. But you have incredible experience in integrate. Yeah, I mean you find yourself doing system integration, so you can integrate with any system, right? Today. Any few words on that?
Pretty much. Yeah. So there's a lot of integration that we have done in the past from different ERP systems, MRPs, connecting to the PLCs and getting data in. The system can actually interact with other multiple different systems. So you will get some data sets from an ERP. You're going to have data from a PLC coming in. You'll have some kind of a tracking environment if you have barcode, RFID, and you'll see that as we go through the data-driven digital twin and how you can actually make all that connectivity in. So I'll touch on a lot of those things as we get into the data-driven section.
Great. Well, thank you for participating in the survey. We'll certainly keep these in mind as we go throughout. But I guess just to answer the cost of implementation, as I mentioned, we just reviewed a half dozen case studies, and they're all between 1 and 3 months. So it's affordable. All right. So with that, we're going to move with Hosni to bring us through the data-driven digital twin overview.
Okay, so yes, sorry, I was on mute. So there's a lot of things that we need to consider when we're doing a digital twin. And the way I break it down is there's really 4 types of digital twin that you can implement. And of course, they vary in complexity and they vary in cost of implementation. There's the initial one, which is the visual twin, is what I call it, which is really an animation of your flow. So if you look at your operation and you put in nice 3D graphics, you let things flow through, it shows the transfer of material and equipment and from different sections of the operations. It looks cool. It's great to convey how the operation works. The only problem is you can't really do anything with that besides that it's a good wow factor and it's a good presentation of what you need to do. So it's a cool animation of the flow. It is a visual twin, except that that's where it stops. It doesn't really give you any more detail on how you can make improvements and optimize and predict what will happen into the operation. The next iteration from there is really using a randomized twin, and I'm going to show you the difference between randomized twin and other types of digital twins. The idea of a randomized twin is you're going to take that visual that you did for the factory or for the warehouse and so on for the operation as a whole. And then you're going to take a time study. You'll go in, do time studies for a couple of weeks. You'll get data. You'll convert it into a set of distributions. And then you put it into that model, and then you start making decisions based on that distribution data set that you created. Basically, what you get is a window into the operation based on that distribution data set. It's really not giving you the full view of what could happen and how the operation could actually behave. So it's purely based on that random data set that you brought in and how those distributions were fitted in order to support the flow itself. The operation after that is to use a data-driven twin. And a data-driven twin does not increase in complexity that much from a randomized twin. It does have a lot of constraints. It has all of the key components of the digitization of the plant. The one thing that it's going to add to the randomized data is that it's actually going to use your own data set. So what happens if you have seasonality, then you're going to load those seasonal data sets into the model, whether it is how the equipment are performing, the work order, the demand coming into the plant, the resource and manpower that you have, any fluctuation that will impact that. So it's actually going to run similar to the plant actually would run. So if you compare, say 2 weeks ago, load that data into that digital twin, you should actually see your plant running or your warehouse running based on that data set itself. The other key important of that is it has to be able to load what we call the current state. So if you're going to do analysis on a digital twin, on a data-driven twin, you always start from a known state that happened in the past, or it could be what's happening at this point in time from the plant itself. And I'll talk about the data and how it comes in here in a second. But once you have that data-driven twin, then you can really turn it into a learning model. You have an environment that basically reacts the same way as your operation. It loads the data and consumes the data the same way as your current operation works. All you have to do now is add that learning aspect of it to say when you have a specific piece of equipment available, just because an equipment is available and I need to do a product or run a product on it doesn't mean I'm going to use it right away. It might actually be detrimental to the schedule if I do that because there's something else coming in the next 15 minutes that'll have better utilization of the equipment itself. So from that point, you will let that digital twin learn from the environment and start giving you better implementation, better optimization on the flow. and it's constantly optimizing in the background to help you achieve where you need to be. So that's really where we're taking that data-driven digital twin environment to be more of an online tool that's constantly looking forward and saying, what could happen to my operation? Where would my delays be? And how can I achieve a better performance, on a, not just on a day-to-day basis, but on an hour by hour, or, depending on how fast your operation is, you can go to even a smaller time scale.
Great, thanks, Hosni.
So,
and just to remind everybody, this is an interactive webinar as much as you make it. So please feel free to ask any questions at any time, especially on these concepts. We'll be referring to them throughout the webinar.
So from that point, the key to what you need to do is first you need to define what your end goal is going to be and why you're implementing that digital twin. If you're only looking for the visual representation, by all means, use the visual twin. You're going to spend the money on it, and it's just going to be different the moment you move one machine or one piece of equipment in the plant. If you're doing that in a warehouse implementation, once you reslot or add another rack, then that's totally going to be different from an implementation point of view. So very important to define what you need to achieve at the end. Then identify your progress. What are your target milestones that you need to hit? What are the key points, the key pain factors that you will need to address? Where your most ROI will be? And set up a plan of how you're going to proceed through. And then once you define that, really stick to that plan. One of the key things of all of the 4 types of digital twin is they're very visual. And whenever they're visuals, people will start to get a lot of different ideas on how things could be identified or how they can be improved. So that identification of the target and the improvement plan is very important going forward. So in a visual twin, you're going to go to visualization only. You're going to create the visual twin, and it's going to be a great way to kind of show people how the plant works today or how the warehouse operates today. You can't use that for any more than what it is. It's just a visualization. It's an animation of the flow. So then you go into the different options and different things that you would have from an operational perspective and identify whether you want that digital twin to be used from an operational point of view, whether you want to use it for connecting to IoT, connecting to other systems and actually do more detailed analysis. If you're just looking for a very quick answer to say, if my capacity increases by 5% a year going forward, will my operation support that? At that point, the randomized twin will give you a pretty good guess. The only thing is that guess is only going to be as good as that data, that distribution data that you fed into it at the beginning. So you just have to be very careful on how you read that. Then you go into the data-driven section where you need to expand. And in the future, you need to go to Industry 4.0. You need to have it as a scheduling environment, or it's going to not purely scheduling, but help you optimize your schedules. You want to connect it to a real time. You want to make it more driven to detailed work instructions. That's when you start tying into the data-driven digital twin. That data-driven now can be used to figure out if you can increase capacity, if you can change your layout, and if that's actually going to work for every single scenario that you might run into, if seasonality is going to impact your operation. All kinds of different aspects will start to impact that data-driven twin. And then you can now connect it to your ERP, MRP, or if you go to the phase 2 implementation where you tie it into tracking data, if you have RFID or if you've got barcode scans, just to identify how that twin actually works. The cool thing about the data-driven digital twin is that it'll always give you the ability to do analysis and forecast, and at the same time, it'll always give you the current state in a visual environment. So I can look at my screen and I can see the full plant and know exactly where every picker, every person is, what part they're working on, how far along they are in the operation process, and it's going to tell me if things are going to be delayed downstream from where we are. So we're going to start talking about the visual data twin at this point, and we'll go into the implementation of what a visual data twin is. And I have a small example of the visualization aspect and the wow factor. The cool thing about all of these digital twins, you can actually implement them with either virtual reality type systems where you can put in the goggles and kind of create that extra wow factor for the implementation itself. So what we're going to do is go through the actual transformation of a digital twin. Going to go through a small plant. This implementation is actually going live. It's in the midst of the transition from fully manual operation into a digitized environment. The same applications that we have on there will actually be used to support many different implementations. So you can have it support, a warehousing implementation, a much larger manufacturing setup, an automation system, whatever other things that you might have from a digital twin implementation perspective. So the way the plant, the current operation is, there's 4 locations that are actually performing the actual work. It is purely built to order environment. There is a kind of a set of product families that they run through, but most of it is based on customer demand, and there's a work order that comes in for specific detail on what they need to do, and that goes into the shop to be processed. So it is a very high mix, highly variable type environment. As I mentioned, they have 8 different product families, and they're really kind of very broad from that perspective. They just, from a routing perspective, those product families really impact the flow and which equipment they can use. But most of the other stuff is driven by the actual products. There's different equipment. The layout is not optimum. It is set up based on what they decided at that point in time to put in these large pieces of equipment. Some of them are monuments, they cannot be moved, or they cost a lot of money to move. So whatever implementation has to go in has to be cognizant of that setup. The good thing for them is they have a pretty flexible workforce, so the people there can transition from one operation to the other, which in a lot of cases is a good thing. In an unorganized environment, it really can work to your disadvantage from that point of view. There's a lot. Everything is manual, from material handling and moving of the pieces, and these are all heavy type equipment or heavy type pieces that are that they're moving. So just a guess. I don't know if you guys have guessed already from the screen of what kind of operation that is, but they actually make granite, and it's a granite operation. They do different types of granite, quartz, limestone, whatever you need to put in your in the kitchen, or tiles and anything of that nature. So just to give you an idea of what the operation actually is. So the plant actually is organized this way. You have inbound inventory that comes in from their main dock door. Everything is going to go through the inbound section. They have 2 sets of inbound inventory. At this point, when this project initially started, the products and the families were mixed. So at that point, we actually worked with them to organize this, and I'll show you how that was done using RFID data. The shop manager will actually identify what the schedule is going to be and how the shop is going to run. They have 3 different cutting machines that are going to cut the granite into small pieces. So you're going to get the slab or multiple slabs of granite coming in. They will be moved through a fork truck. They will be assigned to one of these cutting machines. They will load it manually onto the machine. The machine would run for a specific amount of time, depending on how many, what it's cutting. Then the pieces are pulled out and put on a cart that moves to a polishing machine right in the middle of the full operation. And that finishing area all the way in the back that's when they actually put in an edge to it, they clean it, they polish it so it's got that shiny look to it. And then it goes to a QA operation and load it into, if a different type of cart, so it can be transitioned to be delivered and installed at a client site. So it's as you can see, it's a very manual operation from that perspective. So we're going to just go through that transformation of how they got into the digital twin, and they're actually going now into that learning phase of a digital twin. From a visualization point of view, the visuals for this type of operation are not kind of the best thing to look at. So I figured from that implementation, I'll show you a visual of a much nicer layout. So what you would see there is this is really a wow factor. I'm going to just advance this video there so you can actually see what's going on. So this is a bunch of ASRSs that are going in, robots and material movement and so on. And this is all great. It's very visual. It's going to show you what's actually happening within the operation itself. But this specific representation of that operation is purely visual. There is a rendition of this that actually takes the visual aspect and actually be transitioned to a fully data-driven implementation. But this specific project initiated to be a pure visual representation of a digital twin. So that's where it all starts. From there, you can create the visuals, you get some interest from different, if you need to get the buy-in from anybody on the higher-ups or just to create that extra interest in the implementation, that's really what that phase comes in handy. Besides that, it's visual. You can't really make any decisions based on the values. You can't figure out how fast these things are going to run, or how much capacity you can handle through that operation itself. So you really can't. There is no action that you can take from a visual twin at that point in time. So now we go into a randomized twin, and it does contain all of the constraints of the plant from an implementation point of view. Any rework that's supplied, for example, 5% or 3.2% of finishing will need to be reworked after they hit QA. There's some slabs that break while they're being cut because the saw was not set up correctly. So all these are kind of QA and rework things that need to be handled within the digital twin, whether it's randomized, data-driven, or learning twin. All these need to have those into the operation in order for them to be meaningful in some ways. So what you're going to see is an implementation that shows a very quick representation of the flow. It's all driven by randomization. So let me turn that on. I'm going to switch to a different section here. Oops. So what we're going to do is go through a representation of a randomized digital twin. So you can all see the model there. This is the actual representation of the operation itself. So there's the layout there is loaded, and this is a true-to-scale CAD layout in order to support and identify the distance of travel that anything will take within the operation. So depending on where they actually pick from their inventory, how the items would actually work, the slabs, the pieces will go through, that's all identified within this. And that was the initial representation of that digital twin type implementation. So I'm just going to speed things up here and kind of start jumping through time to actually show the representation of the twin. So again, it is animated, and you're going to see the fork truck moving. You're going to see things going through. That animation is going to be the same for everything that you have. The same animation could be done in a 3D type representation, just like you saw in that video. So it all depends on what you want the visual to be from the representation point of view. Now, all this data is going to compute a randomized data set. For example, a finishing environment is going to take, on average, 120 minutes to finish a job of a granite type. Now, from that point, what you will identify is you put in a distribution and you say granite job could take anywhere between 3 to 4 pieces. So based on my data set that I've collected, it's going to take X amount of time to handle a finished granite work order. I'm going to put that into a distribution, whether that being a normal, a Gaussian distribution, or whatever distribution you decide to go with, and it's going to run the plan. So that's going to give you that distribution level type analysis. So what you're going to see is data based on distributions itself, not based on what's actually happening in the plant. Now, the one thing that you have to really be careful about in here is when you run these, it's going to start giving you data on a per day, per hour, what your lead time is going to be for each one of these jobs. But again, these are based on random data, so you're going to get randomized data sets coming out. I'm not saying that randomized data set is wrong that's being displayed. I'm just saying it's not as accurate as it needs to be in order to do valid decision and valid implementation improvement on the operation itself. So by having that randomization factor into the operation, you're actually taking away some precision from what the actual model is giving you. And normally that's going to be impacted by how variable the operation is. In this specific environment, it is highly variable. So a granite job, for example, or a marble job could take anywhere between 60 minutes and 180 minutes, depending on what you do in each one of these operations, especially in cutting. They have different cutting speed. The saw needs to be run at a specific RPM in order not to break the slab. The amount of linear feet that you run through is going to vary. So all that is really going to impact the operation and is going to impact the data that's being presented. So that's going to give you a good representation of where the data and how things are going to flow through. It's going to give you a representation of where the actual setup is. As an example, we can just go in and say, well, what's my spaghetti diagram for this type of operation? And I can start looking at those from a representation point of view to see what the spaghetti diagram is. Let me turn this on so you can actually see it. And what you'll see is the spaghetti diagram is going to be the same regardless of the operation itself. And it is going to be identified based on color of travel. So that's how they're actually moving within the shop at that point in time. Now, the importance of that is to actually see where there's the traffic, where's the main key of congestion that's actually happening in the operation itself. And right away, as soon as I turn, that identifier, basically the heat map of the operation itself, you can see that the polishing station is really in the wrong spot in the overall process. And it is kind of the controlling factor of the overall operation. So that's the randomized twin actually allows me to see that. It allows me to see how the flow is. It allows me to create some kind of a direction of where I need to go. If I need to use that to identify if I need to buy another cutting machine, or do I need to buy another saw? A randomized twin, if I make a single run, it's going to give me a random set that might indicate that I need to buy a new one, but it could be just the fact that the randomized data happen to indicate that. So in order to actually support that, you have to run a set of Monte Carlo simulations to actually allow you to achieve that type of implementation and that type of result. So that's kind of the component there that I always caution people is if you do a randomized twin, don't use the data right away from a randomized implementation and assume that that's going to actually work directly for your operation itself. It's really going to be a multiple Monte Carlos that you're going to run. You're going to look at the actual data that's coming out and try to see if it actually makes sense from a randomization point of view.
Yeah, and just to build on what you said, Hosni, when you're using randomized data, it's all based on those assumptions, and you're really looking at data in arrears, not forward, and so you're going to be, if your workflow changes in the future, or you think it's going to change in the future, and you start putting in new distributions, that's also somewhat dangerous because you don't know what those distributions are. So it's good from a high level perspective to optimize overall, but not to make really more tactical level decisions. Did I say that right?
Yep.
So it's good. It's better than not doing just a visual.
Exactly. I mean, each one of them is really building on the one before it, and it's providing that extra level of detail that is required. The key aspect of it is that when you go from a randomized to the data-driven, the amount of extra work that you have to put in is really is very minimal, but it's going to give you that detailed representation that will give you upward of 99.5% accuracy from a model perspective. So now you can make those decisions and say, yes, I can support my flow based on a high volume type day and a low volume type day, and on average my days are going to be running in a specific type of implementation driven by actual data that you're going to load from your ERP system. So in a data-driven environment, you're going to load data, and the data could be in multiple data systems, and that's really the key. Is you're going to load some routing data coming from ERP. You might have scan data that's coming from a barcode scanning system or a work instruction type implementation. Some might be in an MRP system. You might have PLCs that are actually generating data to tell you when the equipment or what kind of maintenance is required, how well those machines are actually working. So those are all key data components that you can tie in. Now, keep in mind, you don't have to tie everything in together to get it through the data-driven twin. You need to get enough data so it is a true representation of the plant. So PLCs may not be always integrated into the data-driven twin early on in the cycle, but the ERP data and the MRP are always at the forefront of that integration piece. And what we have been able to do is either tie in directly into those systems and pull the data, or you can get the data in and pass it on from an Excel type interface. So from that point, you actually will start to get a true current state of the operation, and the implementation itself is going to be different. So what I'm going to share is an actual representation of the twin, so of a data-driven twin, and I'll show you basically the differences between them. So what I'm going to do is switch here to the data-driven twin, and I slightly changed my icon so I can identify which one is which. The visuals are the same. The visuals don't change. You can make them, again, whatever you want. The difference between the two models is now to do finishing or to do cutting, it's not based on a distribution. It's based on what that order is and what kind of slab it has and what kind of finishing it needs and what kind of edge you need to have on that job. So this is actually data that we pulled in directly from their systems. And what you would see there, I don't know if I can zoom on this if needed, but what you would see there is different order numbers. There's a material that's actually going to be tied in. We have the colors, the edges that needs to be done, and this is the number of pieces. And this is very key, both in the cutting and the unloading cycle and in the finishing cycle, because that's extra handling that needs to be done. And there's the linear feet that's being computed and actually put in from the implementation itself. So that's the data that actually will come in from the ERP into the op order, the shop floor manager, or whatever is running the operation at that point. At the same time, we're going to look at the equipment performance and identify that depending on which one of these machines we're using, they have a different cycle time per feet and for a cutting machine, it's going to be per cut. So if they're cutting granite and it is a specific, the M1 machine, then it's going to have a specific time per feet. So if I'm using a granite and I'm on M1, that's going to be the amount of linear feet per minute that I can actually cut effectively without making any adjustment. And we kind of adjusted this where per linear feet, and this is used later on for maintenance aspect. And I'll show you that when we actually attach it to the learning system, because that's going to tell us ahead of time when I need to change the blade, when I need to clean the nozzles, all these different components that are actually required to keep the machine running. And I can do that in real time without impacting the operation based on the work orders that are actually coming in. At the same time, I'm going to look at the product routing, and this is basically the type of route that the product is going to go through. So going from the actual operation, depending on the actual part type, this is really the product family. It's identifying the route, the sequence it's going to go through. What you would see here is primary equipment. So if I'm using granite, if I'm cutting marble, for example, I'm really going to try to hit that M1 machine. The M1 machine is better suited for marble type cuts. So from an optimization point of view, I need to maximize marbles on that machine. At the same time, if you look at granite, granite could go on multiple different stations there, and granite can only be cut on M1 and M2. So now I have that constraint that's kind of building into the plant from an implementation point of view. Okay, there's a setup time that's associated in minutes. I did change these slightly from the actual implementation, just not to give out specific detail. And then tooling is really applied to tie in on the finishing side. This is where the next iteration is going to be for this type of implementation, is tying in tooling and tying in the Vries system so that we are tracking how many pieces of tooling they actually use. And these are all small pieces that are used in either the finishing area or material that is required for the cutting saws that are needed. So that data is going to go in, and it's going to dictate how the model is going to run. So when I run this one, you're actually going to see the representation is going to be very similar. The results are going to be different though. So the key there is, although I'm running things based on the same visual, the same path that needs to be made, what's driving the model at this point is this data set that's actually telling me what that order is. So as an example, and from a digital twin perspective, let me pause this for a second here, and I can hover over one of these jobs. And what you can see is this is a cut piece. It does have an order number. It is a type granite, and it's got a certain linear feet associated within those two pieces that need to be performed on that specific job. You can go to a different one, and it's going to be a total. This is a marble piece that needs to be cut, and it's 139 feet. So now I'm actually loading that data set, and I'm running that data into the plant. So when I'm doing my analysis on the operation, and I say, if I do add another cutting station, if I add another saw or add another finishing table, or for that matter, change the layout of finishing, would I benefit from the operation itself? I can load my data set from last week and say, last week I was doing X number of jobs per day. My lead time for each one of these jobs was X. I run it with the new layout. I'm comparing apples to apples at this point as what actually went through. And I'll be able to see that, yes, my operation is actually going to benefit from that, or it's going to get worse. Keep in mind, not every change is going to be as an improvement. There's a lot of changes that are made that actually will put things backwards. And automation is not always the solution. It is a solution in some cases, and adding automation sometimes does not either fit the culture or does not fit the flow itself and how things are operating. So there was an analysis actually was done that to put a crane to eliminate the fork truck, and that created an extra constraint within the operation itself, just because of the way the layout is set up. So at that point now, the digital twin is very representative of my operation, and what they can do at this point is, at the beginning of the day, they know exactly how the day is going to run. They know how many finishing tables they're going to have. They know how many people they're going to have running at each one of these stations. They have a schedule to be released from inventory. So instead of having all the inventory come in, they used to actually pull all the inventory at the beginning of the day and stage them right there to be cut. And that created a congestion for anything that's actually leaving the operation to go to the shop for installation. So by streamlining those and assigning different pull rate from inventory, that reduced the impact on inventory on this side and reduced the traffic. At the same time, it allowed them to have better receiving processes throughout the operation. So it's got many benefits from that perspective on that data-driven twin.
So sorry to interrupt, Hosni. We are coming up on the hour, so if there are any questions, please ensure that you ask them. We will keep going. We might have to go about 15 minutes late, but if you have questions now and you have to go, please make sure you ask your questions in the chat box or in the Q&A, or you can follow up on emails with Hosni or myself, and we'll get back to you. But we want to get to the learning digital twins next, right?
That's correct.
So the one thing that I thought was interesting, and I think I saw some comments on, is around bottlenecks, of identifying the bottlenecks with the data-driven digital twin. The bottleneck often changes depending on the workflow. And how do you manage identifying those bottlenecks so you can be more proactive?
So the bottlenecks are going to be very apparent in the digital twin, in any one of either the randomized or the data-driven twin. The data-driven twin is going to show you more representative bottlenecks based on how you're running the operation. So the way you release the orders into the plant is going to have a huge impact on how the bottlenecks actually come up. Unfortunately, this run right there took out all of the delays that you would have on this area. But based on their order release, what I mentioned before, is in the morning, one of their processes was the shop order will come in and says, I'm going to look at all the slabs that I need to cut today. And before I do anything, I'm going to go to inventory. I'm going to pull all of them here and just line them up. And that actually created a bottleneck within the operation. So you'd have, 20, 25 carts just waiting in here to be cut. Everything else in the plant is empty. So what that created is that congestion from QA basically to leave, and jobs that have completed the day before, they could not be released, and they could not start the installation until about 9:30 in the morning. So those trucks could not leave till 9:30, and they actually needed them to leave at 7. And that created a congestion. In their mind, it was actually improving the operation. In reality, it was making things a lot worse. And by showing the animation of that delay, you were able to see that. The other aspect of it, as you see with the heat map section, you can actually look at that bright red colored area that's showing the bottleneck. You can show it as items waiting. You can show it as just an implementation of a color change. The cool thing about any one of these digital twins is that it's actually going to compute how much delay that's creating. So one of the things that we run into quite a bit is they will say, well, on average, the part waits 35 minutes before it enters the polishing station. So I actually introduced 35 minutes of wait time into the digital twin. Please don't do that, because then you're introducing 35-minute cycle into the operation, and it's not how the operation works. That 35 minutes needs to be eliminated. So the environment is actually going to tell you that you have a X number of minutes of wait time, and as you improve your flow, that wait minute is going to decrease. So that's just very important from a bottleneck detection perspective.
Okay, we're at the top of the hour. We're going to get to the fun part, the learning twin. So. All
right. So sorry for running late. From that perspective, we're going to go into the learning twin. And in the learning twin, really what you have is you have the data-driven digital twin in the heart of this thing running. We're going to connect live to the ERP and the data streams that you have that are going to provide data. So the learning data twin, the digital twin, is really going to have as much data as you can throw at it. The more data, the better it's going to learn, the better it's going to behave, right? So ERP, PLCs, SCADA, any custom implementation, if you are using guided vehicles, AGVs or STVs, and all that data could be fed into the digital twin from that point of view. RFID, barcodes, they're invaluable, and if you want to have that extra visibility into the operation. And then from that point, any tooling type systems or any additional systems like the Wiser consumable tracker. So by tying that consumable to what's actually being produced and how much usage you have for each one of the different items, now you can actually feed that data back into Wiser, so you can do the proper replenishment of those units of the tools as needed, and so you don't have more than what you need of the wrong type of tool. So let me switch here to what you would see actually from a data-driven type implementation. So once you go into the data-driven twin, learning twin, the interfaces will actually be more driven towards web interfaces, because that's going to be viewed by a lot of people throughout the organization, and it's not just limited to the people who are doing the analysis and the optimization. So I can, from that point, for example, look at the current state and see what's happening at each one of these stations. So I know when each order number has started, this is a snapshot of their operation. When they're started and where they're actually going to be in production. So all that is delivered and made available. Then you can actually go into specific representations there and see what actually happened within the flow itself. So based on what we have and what it knows, it's forecasting that in the next before the end of the month, they're going to have 283 additional orders that have to go through the finishing cycle at this point. So this is, and there's 5 that are pending that still have to be scheduled on the operation itself. So all that data now is going to be available to anyone who is either on the finishing side, on the management side, the shop floor side, and it's all real-time data coming from the plant itself. From that point, you look at the actual machines, and you're like, what's going to happen to my machine from that point of view? What's my blade saw doing? What's my utilization? Who's doing different tasks on the operation itself? So the key there is you're seeing the remaining blade life on that specific saw, and it is consuming water, so it's actually generating the gallons per hour that it's consuming at that point in time. Of course, the utilizations and the efficiencies, and these are all the error codes that you get for that machine as it's going through, along with expected maintenance that you would have going into the operation. So these are all identified based on the learning system. So the system in the background is looking at the data. It's actually running through a neural network that's learning all the intricacies of the environment itself and generating the forecasted data set for that implementation. You can look at a forecasted schedule of what's actually going to be based on what they have, and this data set will identify what's the expected lead time for each one of these operations going forward based on the forecast itself. So these are different things that could be set up. Now, what they're proceeding at this point is the next iteration of this is to tie in the RFID implementation into it. And that's where each one of the slabs, each one of the pieces, each cart, each material handling piece of equipment is actually being tagged and identified. So these are kind of different screens that help them on a tablet to scan and identify and assign the barcodes. So when an order actually comes in and it's being released to the shop, they go in and they induct the order by creating an RFID tag and attaching it to the paperwork for the order. That gets assigned to the cart. So the system in the background, as soon as it sees that there's a cart and an order that are within proximity of each other, it's creating that association of the cart and the order, and then it starts to move through the operation itself. As the operation continues, and a worker comes in to move that cart, it's creating this association that that specific person moved that cart downstream.
Are you sharing your simulation screen or the PowerPoint screen?
I'm sharing the PowerPoint screen at this point.
Oh, all right. All right. Good.
So from that point, you can also tie it into that integrating tooling, and that's the other part that's going into is to identify when you actually need that tooling based on consumption rate. So the PLCs are providing data on what needs to be produced, or what is being produced, and what the consumptions are for each one of these components. The work orders and what needs to be produced is looking ahead to say that in 20 days, one of the saw blades needs to be replaced. That tooling is automatically put into the system. It will be available when that blade needs to be replaced and when it's scheduled into the operation itself. So there's also unscheduled downtime that's going to happen, just like any other piece of equipment. And those it'll be identified, and it will plot when specific pieces of the equipment actually will go down and will adjust. I kind of went through this one a bit quicker from a timing perspective. These are just sample dashboards that I actually showed you early on from the actual system, and that's available for them to basically use. So the key to all this is this model, this future state computation is actually performed every 30 minutes for this operation. The data and all of the forecasted analysis is generated every 30 minutes, and it's based on that real-time data and that current state of the implementation. It's identifying all the manpower allocation that they need. Anything that's going to be delayed is visually viewed on those dashboards, and then it's moving into full optimization of the schedule. So instead of the releases being done by the shop manager identifying what I'm going to release today, the system is actually going to reshuffle those orders to maximize the efficiency and send the orders through. It's all driven, as I mentioned, by a neural network that's driven in the background that learns from the environment itself, and it's providing that optimization in real time into the operation. So that's kind of the overall view of the system itself, and kind of all the different interactions that you would have. It actually will generate. Didn't get to show you the value stream mapping, but each one of these digital twins actually generate a value stream map that is representative of the operation itself, and it's representative of the current constraint of the line. So it's not a value stream map that was done based on a specific time study that was done sometime in the past. It's actually your current value stream based on current efficiencies, current wait time, value added, non-value added time, and lead time on the operation itself. So that's really the key component of that dynamic value stream that's changing based on the operation itself and how it's being affected by the different constraints within the implementation. Just some sample dashboards that you can get. This is from a different system that was implemented, and it's just a different type of graphs and different types of values that you can display basically for that. So Jim, I'll turn it over to you.
Great. I think the key here is that what we used to do with rolls of paper and team meetings, and not to say that you don't need to do those type of activities and get alignment with everyone, but when you combine this visibility with those team meetings and you're looking at the actual data, those meetings as far as changes and improvements that you need to make in the manufacturing floor, in the hospital, whatever the application may be, in the supply chain, you're able to have meaningful conversations on actual data using that data-driven digital twin. And if you can get to the learning system, of course, there's huge power. So this roadmap is a pretty classic roadmap of readying for digital transformation and realizing that transformation. These roadmaps we built 10, 20 years ago, and the timeline for this would be months or years to get through here. And I think what's pretty amazing with what Hosni just showed you in a piloted area, that you can move through all these stages and get to predictive, prescriptive, and move to that data-driven twin, digital twin, and move to an environment where you're driving decisions on real-time basis from an action planning perspective is pretty powerful. So what we used to talk about years, we can do in months now, and it's affordable with the system. This is a very high level overview of the rollout, but you can move in a pilot area, and you want to, of course, pick the area that is your greatest constraint. You don't want to optimize your best part of your plant. You want to optimize or gain improvement of whatever is causing the greatest bottleneck in your facility. So very affordable, empowering, working with your teams. The 30, 60, 90-day action plan is very affordable and user-friendly for the folks. So we're running out of time, so I'll just end it right there. There is a last question on how you would rank the benefits of digital twin. Folks have ranked visuals and the full scale prescriptive analytics as number one, and then some online predictive analytics, and then the small scale. But encourage you to think about that we always want to impress management and do the big thing across the board, and we need that visualization with business intelligence, but actually feet on the ground, showing results, getting a return on investment of 1 to 3 months for a new tools and methods, and aligning personnel to the overall goals of the organization to drive productivity. This is something that is very powerful. And with that, just wanted to close with, we at EIG, our group of companies, and Hosni is being one of them, we get together and we built this chart that says, that there's really 3 pillars for digital ecosystem transformation. You have data, visibility, and artificial intelligence. All these are needed. And this just shows a little bit about our partners that cover all these different areas. And obviously, from a visibility perspective, CreateASoft provides quite a bit of value and does use artificial intelligence. But we also have other folks that are focused in other areas. So together, we can cover quite a bit of ground. And with that, that concludes the webinar. Again, thank you so much for joining us. I hope you found this worthwhile. We apologize for running a little bit over. We have a webinar coming up on Thursday this week, then Monday or Tuesday and Wednesday next week, as we mentioned at the beginning. So we hope to see you there. Again, thank you. We believe in people, process, data, technology. Without people and process, any technology that you implement is not going to sustain itself. So with that, Hosni, any closing words?
No, just thank you everyone for attending, and looking forward to the next iteration of this implementation.
Thanks so much, Hosni, for sharing. It's quite a bit of information and very interesting. And I believe that if anyone has any questions or comments, they can reach out to Hosni or myself and Chip with Wisers if you're looking for that type of system. And we look forward to seeing you in a future webinar.